Our today's lesson is measures of variability. So given a data distribution, we're going to use this particular measurement in order to understand the porosity of the data, which means how closely the data are associated with the mean, or how far the data is scattered from the location of the mean. So the measure of variability is primarily measured by three things. One is the range of the data, and the variation of the data, and the standard deviation of the data. So by the end of this section, we will be able to understand and calculate the range of a data set, explain in our own words what a deviation is, calculate the variance and the standard deviation for a population or a sample. The range of a data set is the difference between the largest value and the smallest value in the data set. So how does that help us understand the porosity or the well-packedness of a data? So think about a classroom. There are 30 chairs in the classroom and only 5 students has shown up. Then there are 25 empty chairs. Similarly, if you have a data set with a big range, that means bunch of chairs, but the number of data in the distribution is very small, that means the number of students present is very small, then we call the data set a sparse data set. There are a bunch of holes in the data set. They are not good representative data. They are not packed. The other ways of understanding the variation of a data is finding the statistics variation and standard deviation. So to understand that, we will start with the definition of a deviation. A deviation for a given data value x is the difference between the data value and the mean of the data value. So x minus x bar is the deviation of the data x. For a population, the deviation equals to x minus mu, where mu is the mean of the distribution. If the data value x is larger than the mean, then the deviation, of course, is going to be positive. If the data value is smaller than the mean, then the deviation will be negative. If the data value x equals to the mean, then the deviation is 0. The deviation can roughly be thought of as the distance between the data value and the mean, except that the deviation can be negative while the distance is always positive. A population variance is given by the Greek letter sigma squared. Is the mean of the squared deviation in the population given by the formula sigma square equal to sum of the deviation x minus mu squared. So you find each of the deviations, square them, divide by the sample size of the population, you get the variation. And the standard deviation of a population is given by the Greek letter sigma, which is as simple as the positive square root of the variance. For the sample, the variance is denoted by the letter capital S. S squared is the variance, which is the mean of the squared deviation in the population given by the defining formula S squared equal to sum of the square of the data minus the square of the sum of the data divided by n squared. So in other words, if you find the deviation of each data, so x minus x bar for each data, square it, add them, and divide by the sample size minus 1, then you get variance. So s squared is equal to sum of x minus x bar whole to the power 2 all over n minus 1. And as usual, the standard deviation for a sample will simply be taking the positive square root of the variation. So we are going to start becoming familiarized with the concept of standard deviation. So I'm going to find standard deviation for a simple set of data. So for example, this data set has the data, and we are going to find out the range standard deviation of the following data set. So range, remember the range of a data set is the highest data minus the lowest data. The highest data in this distribution is 25 and the lowest data is 0, so the range is 25. Now think about the empty chair situation. So the range of the data is 25. But how many data we have? We have only 5 data. So out of 25 chairs, only 5 of them are occupied. So the classroom is filled in with empty chairs. That means this data distribution is filled in with holes. So the data are very sparse. They're scattered all over. So now we are going to find out the standard deviation and remember the entire process. So what we will do, we will write down each data with their frequencies. So 0 has appeared with frequency 1, 10 has appeared with frequency 2, 15 has appeared with frequency 1, and 25 has appeared with frequency 1. So the sum of the frequencies is 5. Then I'm going to multiply the data with its frequency. So 0 times 1 will give me 0. 10 times 2 will be 20, 15 times 1 will be 15, 25 times 1 will be 25. And if I add them all, I'm going to get 25 plus 15 is 40, plus 20 is 60. So that is going to help us find the mean. So the mean is this sum, 60 over the sample size, which is 12. So now I'm doing data minus the mean, and this is called the deviation. So you're finding the deviation for each data now. So data is 0 minus the mean 12, so that's negative 12. 10 minus 12, so that's negative 2. 15 minus 12, that's 3. 25 minus 12, and that is 13. Now I do the deviation square. So negative 12 squared, and that should be a positive 144. Negative 2 squared, so that's 4. 3 squared is 9. 13 squared is 169. And I'm going to multiply each of these deviation square by the corresponding frequency. So I get 144, but the 4 I will multiply by 2 and get 8. And then 9, and finally you will get 169 times 1, so 169. And we're going to add them. 4 plus 8 is 12, plus 9 is 21, plus 9 is 30. 3 carries on, 3 plus 4 is 7, plus 6 is 13. 1 carries on, 1 plus 1, 2 plus 1 is 3, so 3, 30. And remember, the standard deviation is coming from the variance, where the variance is s squared, which is the sum 330 divided by sample size minus 1. So I do 330 divided by 4. So I will get 4 times 8 is 32, and 4 times 2 is 10, 8.5. So the variance is 82.5. That means the standard deviation is square root of 82.5. And let's find out how much is this number. So 82.5, and I'm going to take the square root of that number. So round to 4 decimal places, and I will get 9.083. 9.083. That's the standard deviation, which is again expressing large variability in your data set. So then the next example, we are trying to understand the variability of the data set by using graphs. So we have been given with 4 graphs and 4 different situations of mean and standard deviation, and we will understand which situation corresponds to which graph. If I look at the first graph A, then I will see that the range of the data is from somewhere near 20 to 70. So the mean cannot be 75. So this is one of the situations between 3 and 4. When you look at the second set of data in B, the range of the data is from 50 to 110. So this is a large range of data. Mean could be 75. Whereas when I'm seeing the data set of data in number C, the range is from negative 30 to 100. So again, this situation, having the mean at 75 doesn't make much sense. So I will say part A and part C in the graph are the mean 50 situation, whereas part B and part D are the mean 75 situation. Now if you look at part A and part C, it seems like part C, the values of the data, they differ a lot. They have a larger range. So that must have a larger standard deviation. So I will say mean 50, larger standard deviation of 20 is the graph C. Whereas part A of the graph is mean 50, smaller standard deviation because they are kind of clustered close to each other. So that's mean 50, standard deviation 10, and I will say this is A. Similarly, between B and D, B, the data are clustered closer corresponding to the data in D. So D will have a larger variation, and hence I'm going to go ahead and say that the graph in D is mean 75, standard deviation 20, and the graph in B is mean 75, standard deviation B.